Hey guys, sorry about that. This should be crystal clear. I'm using Zoom instead, so I might just have to go to that. I don't know. The meets and the Schoology, I think, are just bogged down. So anyway, just a couple things with your test. So first of all, I'll screen share here. I'm going to bring up the packet. Just as far as when we're testing, first of all, this packet is due Tuesday. I'll have a Google form for you to submit it on. Actually, Tuesday or Wednesday, depending on when you're taking the test. So A group, you will be testing on Wednesday during the hour. It will be timed for 45 minutes, no calculator. B group, you will be taking the test on Tuesday, also timed for 45 minutes, no calculator. Distance learners, you guys are all going to take it on the second day on Wednesday, the 23rd. You're going to take it at your class time. So you don't get any time during the day or as much time as you want. You're going to take it during 5th hour. I'll be sending you a link sometime this week, or I'll put it on the slides. I'll probably send it and put it on the slide for you to join either a Google Meet or a Zoom, depending on what seems to be working better that day. And in that Zoom meeting, I'm going to post a link in the chats. So you'll open up the chat and you'll see access to your test. You guys, though, distance learners, you're still timed. You're just going to get a little bit more time, not for testing, but for getting in, viewing the test, and then also when you're done, you're going to have to take pictures for me and send them to me on a Google form that has a timestamp on it. So I don't want you guys, it's not really fair if you guys get unlimited time. Can't really make sure you're not using your calculator, but I made the test in such a way that it's not going to be helpful because most of the points are for your work that's shown. So the calculator is just going to slow you down and it's not going to help. So back to what's for sure on the test. Yes, for limits, I will ask you 2 limits. One, I believe, and one will for sure require L'Hopital's rule. So make sure you're comfortable with limits and knowing when and when not to use L'Hopital's rule. Asymptotes, I won't ask you anything about asymptotes. It doesn't mean you don't have to do this page. This page you have to do in the packet, but not on test. That's a pre-calculus topic more than a calculus topic. So as far as continuity, I will ask you to find a value k or find a value of a that makes a function continuous. So this page is fair game. The definition of the derivative, I may have you recognize it, but you don't have to formally do it because that's how it's presented on the AP exam. So if you're not sure what I mean by that, I might ask you the limit as h approaches 0, and again, not this one, but this is what I mean by you need to recognize it, of the natural log of x plus h minus the natural log of x over h. This is the formal definition of the derivative for the natural log function. It isn't the natural log function. Remember, f of x plus h minus f of x is the formal definition of the derivative of x. So this is actually the derivative of the natural log of x, which is 1 over x. Now, if instead here you saw a 1 and this was an e, this is still the derivative of the natural log of x, but it's at x equals e. So it would become 1 over e. That I do have a question about you recognize. It's not worth very many points. It's worth 1 point because there's really not much work to show. If you're like, oh, that's a formal definition of the derivative for cosine. Well, that's sine or whatever, negative sign. That won't be very heavy. For the derivatives, I have you do for sure the main more basic ones. Not the power rules, too easy, but you will have to do the product rule at some point. Maybe it's in implicit or maybe it's in some related rate, but you will be doing the product rule, you will be doing the quotient rule, and you will be doing the chain rule. So all of those, all right? And you will also be doing one implicit. I'll tell you it's not tricky. That doesn't mean skip this one. I'm just saying that's not actually a basic derivative. So make sure you can do implicit, Make sure you can do product quotient chain. Make sure you know the derivative with respect to x of the natural log of u and the derivative with respect to x of e to the u. Those are all fair game. At some point, they might be embedded in another question, but a chain rule like this is to be expected. Like this, I won't make them that hard. Rates of change, you can actually skip this whole page. I believe I've already told you that, and it won't be tested. So not only will it not be tested, don't do this page. Not because it's not important. We do a whole unit. I've told you this already, but distance learners sometimes don't get everything I say. Not like they don't understand it. They just don't have access to everything I say. So this is actually, we do a whole unit on parametric movement. So instead of moving just along the x-axis or vertically, things are going to be moving like this, and we're going to have all those total distance traveled questions and stuff. I will not ask you for a normal line because it's not on the AP exam. You still need to do it on here. All right, because if you were in a Calc 1 in college, you would be expected to do normal lines. They're no more difficult than tangent lines. If you forgot what those are, look on the key because I explained it. I will ask you to write the equation for a tangent line, okay? So make sure you know how to do that. Extrema and curve sketching, I won't have you sketch a curve, but I will ask you any of the following. I will ask you maybe to find an absolute min or max, or both, or relative min or max, or inflection points, or where a function's concave up or concave down when it's given as an algebraic function. So it's, for this one, I could very well ask relative if I put this on here. I might say, where's the function concave down? I might say, what are the inflection points? So be comfortable working with these and be able to ask those types of questions, answer those types of questions. If not, make sure you reach out to me. We will be doing 3 problems on Monday in here that, and I believe one of them is one of these. Related rates, I will ask you one, it will be geometric. So I'm telling you it's not going to be like just algebraic. It won't be a ladder. It's going to be one of the ones like how you practiced on delta math, or like the cone cylinder sphere-ish kind where it's just geometric. It's not meant to trip you up. It's just meant to see if you have the basics down. Mean value is fair game, but I won't ask you about roles. It's fair game that I ask you, is the hypothesis met? Is the function continuous and differentiable? Like, can you even apply it? Or to find the value of C guaranteed by it. Those are both fair game. Next up, for the indefinite integrals, I don't have them as hard as what's on this page. So on this page, I'm okay with you being pretty heavily dependent upon the key. I am going to make them a little bit more just mid-level. Like, these are a little tricky in here. You might say, why'd you put them in here? I actually found this whole packet online years ago, and I like it for the most part, but it at some points it's got extras, some points it's not enough, but I do like it. Like, it'd be more like this one, or more like this one, or this one, or this one. Some of these other ones, if you're like, I had to look at the key, that's okay. But make sure you can do sort of just a basic indefinite integral. Here, I'll put a sample down of what I mean. That's not tricky. A lot of the, like here, you're expected to know that tangent squared is secant squared minus 1, and you know the antiderivative. I'm not going to try to trick you like that. There's a whole chapter, like I said, on techniques of integration. So don't worry about that. But you should be able to do, for example, one like this where you're like, okay, my u is ln x. My du is 1 over x dx. So I have the whole integrand taken care of without even a fraction correction. This is u cubed du, right in my face. This is u to the 4th over 4 plus c when u was a natural log. So kind of straightforward. Or maybe it's tricky, and let me make one up. Maybe there's a 3x cosine 4x squared sine 4x I'm gonna make one kind of hard, squared with the 4x being squared. Sorry, the x being squared, and maybe the sine is squared and then dx. I hope this one works. I'm just making it up off the top of my head. But this is reasonable because we know constants come out front. I've also said when you have these integrands like this, it's always nice to let u be an inside function. Now you might say, well, there's two of them. There are, but the derivative of 4x squared is 8x. It's not the rest of the integrand. Where the derivative of sine of 4x squared is, du dx is cosine of 4x squared times 8x. And you might say, yeah, but I don't want there to be an 8x. I just want an x. Well, that's where you do the 1/8 fraction correction is equal to cosine of 4x squared times x dx. So notice I had the 3 I took out front from the beginning. This sine was my u, so that's u squared. The rest of the integrand, x cosine x dx, was my du. Now I have u cubed over 3 times 3, so that's the type I'm telling you I will test you on. Differential equations, please do this page. It's part of the assignment, but I'm okay if you're a little dependent on the key for it and a little foggy. I will not test you. So not on test, do this page. Next up, the FTC, kind of same as with that last one. I will have you do one definite integral that goes to the FTC. I won't have you do the second fundamental theorem of calculus. For one reason, it's too hard to read them on here. So that's part of it. I won't ask you to do absolute values, so feel free to skip that. I'm not going to try to trick you with trig. You might say she's skipping the whole page, kind of, because I'm not going to test you on this at this level. These are sort of trickier then. So even if you were like, I don't want to do that page, and you're like, but what kind will she have? I'm going to do 1 or 2 on Monday so you can have access to that. But they'll be, again, a little bit more straightforward where I'm just making sure you know the process. So maybe it's e to the 4x, and it's a 3, and it's a dx, and maybe it's from 0 to 1. All right, something like that, where you're like, okay, the 3 comes out front. I have e to the 4x dx. I let u equal 4x. I say, well, du then is 4 dx. And we're like, well, I don't want that 4 there. So I do the 1/4 du for dx. And don't forget to change your limits, right? And go from 0 to 4. It's that type. And we'll practice a little bit of that on Monday. Area and volume, we're not doing any of it. Not because it's not important. That's actually how we're going to start our next unit off. So you can skip these whole last 2 pages. We might go back and I'll recopy them and have them be an assignment in our next chapter. So that should have cleared that up for you. And I'm going to hold the test here and I'm going to tell you, it goes implicit. Equation of a tangent line. A nice normal derivative. Find all x values for which a function is. And I either ask you concave up, concave down, or increasing or decreasing, but it's an algebraic like polynomial function like 4x to the 3rd plus 20x. There's a related rate. There's a definite integral. That's not super complicated. Another derivative rule, product or quotient or chain. A definition of the derivative, a limit, a piecewise function where you have to find k, an indefinite integral, and the last part I'm going to talk about on Monday. So I hope that gave you a good idea of what you need to do in this packet and what your test will look like, sort of. And again, I'm being really transparent about it because this test I really want all A's. That's the whole point. I want us all to have a rock solid base. So on Monday, we are going to do 3 review problems together, and then you're going to take a little practice test on the computer. And then to repeat, on Tuesday, B group, you will test 45 minutes in class, no calculator. Wednesday, A group, ditto. And the distance learners, you will be getting a link to join us. So you will actually sort of be in the room with us up on the screen. You'll just get a little extra 5 minutes to do your downloading and your submitting. All right, I hope that was helpful. If you have any questions, just let me know Monday or Tuesday. You guys have a great weekend. And what did I assign you guys for the weekend? I get a little confused with all the different days. You guys were doing integration techniques on Delta Math, I believe. If not, just go look at this slide. I'll stop sharing. I'm going to say goodbye. Sorry about the glitches. I think every single one of you came to that conference, so that's amazing. I'll try to, maybe we'll just do it through Zoom next time or go back to Google Meet, which I'm not a huge fan of, but it is what it is. See you later.